Hello and welcome to the Omics Casts. My name is Alberto Vilella, and today we're going to talk about new languages in bioinformatics. The motivation for this episode of the videocast, the Omics Casts, is to look at the results, ongoing results for a poll I put on the Twitter that had this question: what new computer science languages excite you the most for bioinformatics? And after a few days of the poll being live, two main languages came to the fore as people finding them exciting: Rust and Julia, with Go being the third one, nim following closely as fourth. And then there's an array of other things that, some of them are not that new, like R or Python, and some others have just started to appear in the poll. And so these four languages, Rust, Julia, Go, and nim, I thought were worth mention in a video cast. So let's talk about Rust first. Rust and Rust Bio. Rust is a computer language. I'll give you some notions of what type of language it is later on. And there is a bio project, a bio repository for the Rust computer language called Rust Bio in GitHub. And this is the starting page of Rust Bio, which is a library or a package that provides implementation of many algorithms and data structures that are useful in bioinformatics, all provided via rigorously tested continuously integration resources. And then it's had 54 releases and 41 contributors. It's released under the MIT license. What type of tools or data structures are available there? Majority of pattern matching algorithms, convenient alphabet implementation, pairwise alignment, suffix arrays, BWT and FM indexes. These are useful for kind of next generation sequencing data sets. QGRAM, PSSMs for people that work with them. CERDA support for all structures nightly. FASTQ, a few readers and writers, the most common ones: FASTQ, FASTA, and BED. And for reading and writing BCF files and BAM files, there is a Rust hts-nim library by Christopher Schroeder. The author is Johannes Koester, and there's quite a few contributors here. It's a list, going to the 20s, 30s, 40s, the top ones here, which means it's quite a healthy project in terms of contributions. And if we look at the live stats in GitHub, it started in anger in 2015, beginning of 2015, and then it's continued with quite a steady amount of progress since then, with Johannes Koester being the lead contributor. And here's the Twitter handle for it. Badim and Patrick as being two bigger contributors as well. Taylor Kramer, I haven't found the Twitter handle. Forgive me if I've missed it. And Pierre Marie-Jo Natir also present. There are quite a few French contributors, but Johannes Koester from Germany and some other American contributors like Patrick, who I think works for 10x Genomics, also being deeply involved. And that's the summary for Rust. What's the second language in number of votes currently? It's Julia. And there's a BioJulia project. It's an older project. The Julia language and BioJulia have been around for quite a bit. There's 15 people listed as contributors to the BioJulia organization, with lots of repos inside. The main repo, BioJL, had a peak of contributions between 2015 and 2017. It seems it's dried up a little bit in the last couple of years, but that does not necessarily mean that the project is not active, because for a fundamental package or library like BioJL, it doesn't mean that it's not actively being used in many places. It just means that the main contributions to this package happened between 2015 and 2017. So less so happening in 2018 and 2019. Here are some of the contributors, some people from Cambridge that you may recognize here. and that's BioJulia, Julian BioJulia. Go. Go is a computer language that was heavily endorsed and supported by Google for quite a while. I don't know if Google has changed the stance since then, but the language has definitely fizzled out a little bit since then. The BioGo project, which is the equivalent BioStar for Go, started in anger with 2012, 2013, 2014. There were a few more developments at the turn of the year in 2015, 2016, 2017, but not much happening the last couple of years. As you can see from the plots here, a lot happens at the turn of the year, right? So when people are on their Christmas holidays or New Year's holidays, and they work on this on their spare time, and they contribute willingly to these open source projects. A lot of it happens in that same way. You see how in 2013, a lot of it happened in the last couple of months, probably most of it in December 2013, another spike in 2014, 2015, etc. And so here are some of the main contributors for Go and BioGo. Finally, number 4 in the poll currently, it's nim, and the closest BioStar that I could find, which is the hts-nim library. This library is written by Brent. Those of you that know him, Brent or Brent_P in their Twitter handle. He is quite prolific in bioinformatics and posts quite a lot of the tools that he releases as open source on Twitter. So it's definitely worth following him. He's mostly contributed by himself to hts-nim, which, as you may guess, it's about next generation sequencing, high throughput sequencing, nim implementations. And this has happened mostly in the last year and a half, between second half of 2018 and up until now. And so that's the number 4 language, nim and hts-nim on the bioinformatics side. What follows after that? I thought it was worth mentioning Ruby and BioRuby, which was a project that was quite prolific quite a few years ago. And you can see here from the trace, I mean, GitHub hasn't been forever around, but you can see here from the trace that there was quite a lot of activity between 2015 and 2012. So 2015 and 2012, it's like 7 years ago. It fizzled out a little bit. A few contributors from Japan, Piotr, for those of you that know him, contributor of Sambamba and other projects, Michael Barton, etc. BioRuby is still alive and kicking, but most of the contributions to BioRuby took place quite a few years ago already. So since Rust has been the number 1 in the poll that I put out there up until now, I thought it was going to be I was going to give a quick intro on Rust as a programming language, which is all the information in the next few slides comes directly from Wikipedia. I found the page quite well kept and maintained. So as an intro to Rust, Rust is a multi-paradigm system programming language focused on safety, especially safe concurrency, right? And you'll see traces of the safe concurrency and memory safety all along the description in Wikipedia. It is syntactically similar to C++ and C, but it is designed to provide better memory safety while maintaining high performance, right? So C and C++ are both the languages historically with which most of the heavy coding has happened when performance is the number 1 request. And they have problems. They're not perfect languages, and null pointers and deleting memory you shouldn't delete and accessing it again are common mistakes that people do when they write in C and C++. And so Rust came with this impetus of safe concurrency and better memory safety. Originally designed by Graydon Hoare at Mozilla Research, the first compiler, Rust C, was written in OCaml, and it compiled itself for the first time in 2011. And Rust C uses the LLVM toolkit as a or toolchain as a backend. So high performance, but with memory safety and safe concurrency ideas at hand. In terms of what it looks like, it's comparable to the performance of idiomatic C++. It's influenced by C# and C++, but also the ML and Haswell languages, ML family of languages and the Haswell language. So it looks syntactically a lot to C and C++. But the syntax of Rust is deeper, in a deeper sense, is closer to that of the ML family of languages and the Haswell language. Also borrowed concepts from Swift, which is another quite recent language that has the backing of Apple. So memory safety, memory management. Rust has been designed, the system is designed to be memory safe, and it does not permit null pointers, dangling pointers, or data races in safe code. That is kind of the number one selling point of Rust when you compare it to C++ or C. This memory management does not happen by garbage collection like it does in Go, Java, or the .NET framework, but instead it's managed through the concept or the convention of resource acquisition is initialization with optional reference counting. And so what this means is that it's deterministic in terms of the management of the resources with very low overhead, because every time an object is created, the memory that's needed for that object to be used and consumed is initialized, and when the object is destroyed, then the memory automatically goes away. And that makes it abide by this convention of resource acquisition as initialization. There is also the concept of references, the ampersand symbol before the function of the object, which do not involve runtime reference counting. The safety of using such pointers is verified at compile time, which is a big advantage for the behavior of this kind of programs. Instead of types, the type system supports a mechanism similar to the type class. To type classes called traits, which is inspired by the Haskell language. It does feature type inference for variables declared with a keyword let. And that is for variables that do not require a value to be initially assigned to determine their type. But from then on, it's all compile time, so to speak. Functions can be given generic parameters, which usually require the generic type to implement a certain trait or traits. Within such function, the generic value can only be used through those traits. The advantage that this has, and the way they behave in contrast to C++ templates, is that there is no implicit duck typing in variable types, and cannot be checked until instantiated with concrete types. C++ concepts address the same issue and are expected to be part of C++20. So for those of you that stuck with C++ and all the very long history of proposals, C++20, C++17, C++11, etc., you will have seen C++ itself as a language evolve to change the rules in a way that programmers feel comfortable with in modern today's in contemporary programming. And Rust, having come in 2011 or so, probably just after C++11, and being more prevalent since then, has taken this stance on typing and duck typing and memory safety from the get-go. Right, I hope you enjoyed this episode of the Omics Cast, and this is the poll from which this videocast was instigated, bit.ly/bioinfo-cs for computer science. And one of the questions in the poll is the one that I showed a few of the current results. What new computer science languages excite you the most for bioinformatics? And here, new is a subjective term, but essentially not something like Perl or R or Python, because those are languages that have been used in bioinformatics extensively. Some of them are still the dominant languages in bioinformatics. The question is more about new computer science languages that excite you, the prospect of which excites you the most in bioinformatics. So Rust and Julia are doing well. Nim and Go are quite doing well as well in this poll currently. Vote if you haven't voted yet, and retweet if you see the tweet and you voted again, so that it gets maximum exposure. As a reminder, here's my Twitter handle, twitter.com/Albert If you want to follow more videos like this or more of the content that I post on Twitter, you can follow me on Twitter. I'm also happy for you guys to contact me via LinkedIn, and I'll try and answer any questions you may have on LinkedIn. This slide deck is available open request. Click like, subscribe, so that I can see who likes what in the contents I put out there, and then we can do a few more of this. Thank you very much, and until the next episode, goodbye.